Good evening, everyone. Welcome to another amazing talk sponsored in our series by Codesmith, Jeeny, and Bractlet. This evening, we are joined by Drew Tucker to talk to us about end-to-end testing with Cypress. So without any further delay, take it away, Drew.
Thank you, Rami, for that incredible introduction. And yes, we will be talking about end-to-end testing with Cypress today. So let's get into it. What is end-to-end testing? So end-to-end testing is a software testing methodology that evaluates a piece of software from start to finish, as if it will be used by the actual users. So this method aims to replicate real user experiences to validate the system for integration and data integrity. So whatever piece of software, the major idea is to run and test the application with all of the dependencies. That means your database, your external services, your metrics, your logging, everything. So ideally, you're creating a test environment that represents the production environment as closely as possible. So why do we even call it end-to-end testing? So let's look at an example. So imagine you have a simple web application, right? So when a user performs an action, like clicking a button, this triggers the front end of the application to send a post request to a RESTful API, which does some processing and finally will add a row to a table in your database. And if we imagine the whole process as a line, as we see on the right-hand side, right, on the end of the line would be the place at which the users interact with the app or the user interface. The other extreme would be the database. This is why we call end-to-end tests their name, because they start at one end of the application and will go all the way through to the other end, including all of the layers and components in between. So let's go over just overall testing strategy and the testing pyramid. So let me just start out by saying that software can and should be tested on many levels, and that end-to-end testing is only a part of a more comprehensive testing strategy. So let's take a look at the testing pyramid. The testing pyramid gives us a guideline of how many types of tests we should have. So as we move up the pyramid, our tests start using more pieces of our application. These tests become slower to execute and harder to maintain. But that's why there are usually fewer end-to-end tests than there are unit tests. At the lowest level, we have unit tests. Unit tests exercise very small parts of the application in complete isolation, and we compare their actual behavior with expected behavior. So because they are easy to write and maintain and fast to run, it's valuable to have many unit tests. But when I say complete isolation, I mean that when unit testing, you don't typically connect your application with external dependencies such as databases or file systems or HTTP services. This ultimately allows unit tests to be fast and more stable since they won't fail due to problems with external services. Unfortunately, though, just verifying that all of those small pieces work in their individual environment isn't enough. We need to prove that they work correctly together, right? So this is where integration tests come into play. In integration tests, two or more components are used together in a test, and the result is verified. However, even though we're so close to the finish line, and even if all the tests run perfectly okay, we still might have bugs or unmet requirements. And I know you're thinking, but how can this be? Well, unit and integration tests don't yet cover the UI. So in order to answer questions like, is this user interface structured correctly? Is it a pleasant experience? Are all of the necessary elements in place? Can the user achieve what they actually want to achieve? To answer these questions, we need to implement an end-to-end test. Okay, so why is end-to-end testing actually important? So end-to-end testing has been widely adopted because it helps teams expand their test coverage by adding more detailed test cases than other testing methods like unit and functional testing. So there are so many moving pieces in modern software, right? So there are servers that can cause applications to behave differently, the configuration must be set up correctly, and external dependencies influence our application. But testing separate components in unit or integration tests will not cover all of this. So end-to-end testing ensures that applications performed correctly by running the test cases based on the end user's behavior. So this helps the release team reduce the time to market by allowing them to automate their critical user paths. Overall, this reduces the cost of building and maintaining the software by decreasing the time that it takes to test the software and detect bugs. So we know why it's important. What kind of tests can and should be run. The first should be a database test. So the database used for your system would need to be tested. You could test to ensure that the data is stored properly, organized properly, can read, and is updated correctly. The second is a performance test. There can be a web page that may navigate correctly, but the speed actually also matters for the user experience. So it's actually important to test the performance of a page or feature. Next, we have a security test. So web application security determines how secure an application is for the user and the organization, right? So the next test that we have is the functionality test, and this is the big kahuna. So this is the main reason for testing in the first place. All features must function as expected. Unit tests can be really applicable here, but we want end-to-end tests to make sure that they all run in tandem. So usability, our final test. As components are functional, they should be usable, right? Users are as important as the tool. So tests must cover events like clicks on elements and proper navigation and so forth. So now that we know what to run, right? How do these tests actually work? So there are 7 major steps to how these tests actually begin to work. The first is that tests are planned and designed for different requirements using testing frameworks or platforms. The tests are then executed, and we see if the tests break or fail. The developer, if it does break, debugs the code that actually broke. The tests are then rerun, and if successful, the tests become automated and directly implemented into the CI pipeline. Now, when we're actually looking to get these tests to work, there are a couple of best practices. So the first is to prioritize the end user. So when creating tests, test like the user. Get into the mindset of someone using the app for the first time. Is it easy to find all the options? Are the features marked? Can users get what they want in 2 or 3 steps? These are important questions that should be thought of and answered. Second, use acceptance testing documents and user stories that actually help clarify the user's point of view. Design these test cases accordingly. The third, focus end-to-end tests on app features whose failure will cause maximum issues. Start with these features and then design more elaborate test cases to actually then verify them. So one point that I did want to focus on was the necessity for automating these tests, right? So as your project grows, performing all end-to-end testing manually will become less manageable. This is especially true of testing user interfaces because an action in a user interface can lead to many other actions or regressions. So what are regressions, right? So some of you might remember learning how to build out your first application. And when you went to fix and detect or add a new feature, all of a sudden another thing stops working. And that is what we call a regression. So since any part of the application can technically interact with any other part, even the smallest change to a code base can cause unintended consequences to a seemingly unrelated part. And software applications are susceptible to regressions. So there's really no way to have the bare minimum of confidence in the quality of your app unless you completely test it after each and every change. Doing this manually would be an impossible task. So even if you could manage to somehow pull it off, the process would be so slow that all of your competitors would beat you to market. Thus, we need to aggressively pursue automation in your test strategy, and we can make sure that we have the confidence in the quality of the code while maintaining the ability to ship it as fast as we need. End-to-end tests can help automate user interaction testing and save us this valuable time. Okay, so now we know what end-to-end testing is, right? We know why it's important. We know why we have to automate, but what kind of solutions are out there for us? Introducing Cypress. So Cypress is a JavaScript-based end-to-end testing framework that conveniently facilitates the process of end-to-end testing by giving the testers the chance to run their testing flows using test-driven development or behavioral-driven development, along with real-time browser interactions. What does all this actually really mean? That we can do 4 tasks incredibly simply. So we can set up tests, we can write tests, we can run tests, and we can debug. So let's go through a quick example. The end-to-end automation testing with Cypress simulates the real-world human interactions in the UI part inside of the browser. So in this example, we're looking at the testing for a login form. The first step is to determine the test flow that is being tested. So this gives a comprehensive idea about the scope of the test to actually be executed. So once this test flow is identified, the next step is to write the test scripts for that test case. After that, we are going to want to execute the automated Cypress end-to-end test and record and analyze the test results that we get. So once the test executions are actually finished, as seen on the left-hand side, the tester can go through the test steps and revisit the step as a real-time intervention, which gives us the convenience of debugging, as well as documentation or analysis of the test results for the tester. So what separates Cypress? Why is it amazing? Why did I come here to talk to you today? So Cypress has evolved the methods of end-to-end testing to an entirely different level. How? So Cypress has an all-in-one architecture for the automation testing. So before the Cypress era, we had to choose components separately for the automation process. First, we needed a framework with an assertion library. And after that, we needed to install something called Selenium with a wrapper for that. And if needed, we had to install additional libraries and tools that would be vital for our testing flow. But that was too much. So with the Cypress framework, we only need to write a test flow in JavaScript, and the test can be executed without adding any hassles along the way to actually achieve those test results. And this is all because of Cypress's ability to offer an all-in-one architecture solution. So most testing tools operate by running outside of the browser and execute remote commands across the network. Cypress is the exact opposite. So Cypress is executed in the same run loop as your application. So behind Cypress is a Node.js server process. So Cypress and Node.js processes constantly communicate, synchronize, and perform tasks on behalf of each other. And having access to both of these parts gives us the ability to respond to our application's events in real time, while at the same time working outside of the browser. So Cypress ultimately controls the entire automation process from top to bottom, which puts in the unique position of being able to understand everything happening in and outside of the browser. What does this mean for us? This means that Cypress is capable of delivering more consistent results than any other testing tool. So another big factor, Cypress is specialized in end-to-end tests. So unlike other automation frameworks, Cypress is not a general automation framework, nor is it a unit testing framework for your backend services. It is specifically created for writing end-to-end tests for your web applications. Cypress's specificity gives you ultimate control over your application, the network traffic, and native access to every host object, effectively unlocking a new way of testing that has never been possible before. Next, it's actually compatible with every other front-end framework. So you can basically test anything that runs in the browser with the Cypress architecture and have it work perfectly. Another big component is that there is no use for Selenium. And finally, Cypress runs much, much faster. So these architectural improvements actually unlock the ability to do test-driven development with full end-to-end tests for the very first time. So Cypress has been built so that testing and development can happen simultaneously. So you can develop faster while driving the entire dev process with tests, because you can see your application, you still have access to the developer tools, and changes are reflected in real time. So the end result is that you will have developed more, your code will be better, and it will be completely tested. So if you use Cypress Cloud, parallelization and automated load balancing will further supercharge your test periods. So in summary, what did we learn here today in this talk? The first, end-to-end testing is a testing methodology that evaluates a piece of software from start to finish, as if it will be used by the actual users. Second, this method aims to replicate real user scenarios to validate the system for integration and data integrity. Software can and should be tested on many levels, and end-to-end testing is part of a more comprehensive testing strategy. We also learned that Cypress is a JavaScript-based end-to-end testing framework that conveniently facilitates the process of end-to-end testing. And finally, Cypress's all-in-one architecture, specific focus on end-to-end testing, and framework agnostic nature offers a best-in-class end-to-end solution. So thank you for your time. Thank you for listening. These are my works cited. And if you ever feel the need to contact me, please feel free to do so. Thank you very much.
Thank you so much, Drew, for that wonderful tech talk. We look forward to seeing all of you in our next Codesmith, Jeeny, and Bractlet Tech Talk. Thank you all so much for being here.